Hey guys, so today we talked about trig graphs, and I just wanted to give you a quick wrap up of what we did in class and also sort of the quick way to graph a trig graph. So if from here on out, when you're asked to graph sine of x, we aren't going to have to fill out the entire table with the whole unit circle. What I will want you to do though is to put a couple key points on it. And so if you just sketch on the side of your paper, or in this case we'll just do it in the free space here, sketch a unit circle and label the points that are on the x and y axes. So here we're over 1 up 0, over 0 up 1, back 1 up 0, over 0 down 1. And then label your radians there too. So 0, pi over 2, pi, 3 pi over 2, and then obviously 2 pi. Okay, so that's pretty quick. That's going to help you fill out the sine curve quickly. So we don't need all of the points in between. We'll just use these like main points basically. And then over here, you're going to draw your graph, and you're going to go out to whatever distance you need to, and you're going to put 2 pi. It kind of doesn't matter. And then you're going to cut that distance in half. So I have 12 units there, so 1, 2, 3, 4, 5, 6 is my halfway point, and I put pi. And then you cut that in half, and you put pi over 2. And you cut that in half here, between the pi and the 2 pi, and that's your 3 pi over 2. So the trick is you just go out and you put your last tick mark, and then you cut it in half, and then cut each one of those segments in half. And from here, we know that sine is the y value. So sine starts at 0. At pi over 2, it goes up to 1. At pi, it's back down to 0. At 3 pi over 2, it's down to -1, and at 2 pi, it's at 0. And then from there, you can connect your curve in. Please make sure to put arrows on your graph. It is the case that we can keep going around and around the circle, which means this wave keeps going on and on forever. And we can also go backwards, so we can go in the negative direction. I'll show you that on the calculator in just a second. Actually, maybe I'll do it right now. So if I was going to graph this on the calculator and I wanted it to look like what I just got, on my calculator, first of all, I'd have to make sure my mode is in radians, so you might have to change that on your calculator. Then you go into your y equals, and I have something crazy plugged in there, so you plug in sine of x. And now I could go to my window button because I need to fix my x and y mins and maxes. Now if I want it to look exactly like this, I would make my x min be 0. My x max is 2 pi, and I can literally type in 2 pi and the calculator will convert that for me. My x scale right now is broken down into pi over 2s, so I can type in pi over 2 and hit enter. My y min is at -1, my y max is at 1, and I didn't really break up that scale, so I'll leave it by 1s. Now if I hit graph, sure enough, I see the exact same curve as we got using our unit circle, which is nice. Now if I were to change my window, and let's say go from -2 pi to 2 pi, you're going to see that the sine curve is really a wave. It's not just one chunk of a curve like we graphed in class today. It's actually a sine wave. And if I were to go from like -100 pi to 100 pi, this might be a little crazy, you'll see that the wave goes on and on and on forever in both directions. And that's because we can keep going around the circle in any direction we want. We can go in the negative direction by going backwards, and we can go in the forward direction as many times as we want. Now, cosine is the same thing. If you're asked to graph a cosine graph, just a basic one, just a quick sketch of the unit circle. It doesn't even have to be pretty. It's just, quick and dirty to get it down. And then you label your 2 pi, cut it in half for your pi, cut it in half again for pi over 2, and a half again for 3 pi over 2. And then if I'm looking at cosine, cosine starts at 1, and then it goes to 0, and then it goes down to -1, and then to 0, and then back up to 1. And some basic vocabulary that you might have heard from trig, but if you took advanced algebra last year, you probably didn't hear. There's some key words here. One of them is period. And no, not, like the womanly monthly thing. Oh, I can't believe I just made that joke on a video. Dios mio. Anyway, it's amazing the things I'll say. So one of them is the period. And the period is how long it takes to go once around the circle. So in this case, we're traveling once around the circle in 2 pi, which means we have one piece of the graph, one period of the graph happening between 0 and 2 pi. That's once around the circle. It's basically when the values start repeating themselves again. So the period of the sine graph, if nothing has changed on it, is 2 pi. And it's how often the graph is repeated. The same thing for the period of the cosine graph, if nothing's changed on it. It's also 2 pi in this case because it goes once through this cycle, once around the circle, and then it's going to repeat this shape over and over again. And then there's also something called the amplitude. And the amplitude is the wave height from the center of the wave. So if I'm looking at this like a wave, this is my center line right here. The x-axis right now is acting as my center line. And the height of this wave from the center of the wave to the top of the wave is my amplitude, which we will shorten to amp most of the time. So in this case, the amplitude is 1. And then here, from the middle of my wave to the highest point of my wave is also an amplitude of 1. It's this distance right there. So on a cosine graph, a regular cosine graph, the amplitude is also 1. A little trick here, amplitude is always positive because it's always a distance, so you shouldn't ever have a negative amplitude. We will, however, tomorrow in class be stretching and shifting and doing all sorts of crazy things that might affect the period or affect the amplitude, might change what the graph looks like. If you want to get a head start on what we're going to be doing tomorrow, you can always play around on your graphing calculator. If you set your window from like negative 2 pi to 2 pi, you get your regular sine curve here. And then if I wanted to mess around with it a little, I could graph my regular sine curve and then see what would happen if I graph like 2 sine of x. And maybe even try and guess what you think would happen and then look at it. Or, for instance, what would happen if you did the sine of x minus 2? What would that look like? Or if you did the sine of x plus 6, right? So this is getting back into our function stuff that we did in chapters like 1 and 2 when we were moving functions around and shifting them and stretching them and stuff. So we're now going to apply that same idea to sine and cosine functions. So if you want to play around a little bit with tonight, especially if you didn't take trig last year, I think that'd be a great idea. All right, guys, I will see you in class tomorrow. Have a good night.